And we have covered different aspects of spatial statistics and econometrics. And in the last class, it comprises basically a set of warnings about when to do spatial analysis, and the possible problems that you may face. So the first problem that you will face in econometrics is something known as the problem of ecological fallacy. Okay, so this is a mismatch between the unit in which you are studying the phenomenon and the unit in which data is available. Okay, what we are basically saying is when you are looking at starting, in any type of analysis, you are studying some behavior. It can be the behavior of economic variables, prices, inflation, unemployment, whatever, or it can be the behavior of individuals or groups. Now, you should be very careful as to what you are studying. Are you studying individual behavior? What is the probability of, if you take the stunting example, for instance, what is the probability of a child being stunted? What is the chance of facing intimate partner violence, spousal violence? Or are you studying in which areas levels of stunting, the proportion of children, a higher proportion of children are stunted? In which areas women are more likely to face spousal violence? So very often we find that the researchers confuses between these two aspects. See, why this is important is that if you consider, for instance, the probability of stunting, age of the child and mother of the child are important determinants. So if you look at an individual child, its age and the age of the mother will determine whether the child is stunted, wasted, underheight, and so on. But if you're looking at the percentage of stunting at a district level, is age of child, age of mother, are they relevant? It is the district level characteristics which are relevant over in this case. So if you're taking, so you have to be careful as to what are the variables which you're taking. For instance, suppose you have an area you want to capture the economic status of the district using income. Suppose you have income data, and there's an area in which you have 10 persons whose monthly or rather annual income is, let us say, 5 lakhs, and you have 1,000 poor persons whose monthly income or annual income is only 10,000 each. So the average of this will be rupees 1,36,000. Now, if you look at the distribution, well, does it capture the situation in the districts? No one has an income, no one in this district, out of the 1,010 persons, no one has a mean income of 1,36,000. Okay. You have 10 persons who have a much higher level of income, and the remaining 1,000 people have much lower levels of income. So a better variable would be to capture the proportion of people, perhaps capture the poverty level, a proportion of people who are below a certain level. These sorts of variable may be better to capture the economic status of a district. So sometimes just because you have a district level variable, don't jump into spatial level models. Sometimes particularly if you're looking at individual level phenomenon, you want to study why a child is stunted, for instance, multi-level modeling may be a better alternative for you. In multi-level modeling, what we do is we take individual level data. So whether a child is stunted or not, it depends upon the characteristics of the child and the parents and the household to which the child belongs. Then we have district levels or block level variables. So these comes as fixed levels. In panel data, you know that there's something called a fixed level, a fixed factor. So you have if you have district level a variable, suppose you have the district level temperature. So this will be a district level fixed effect. Okay, so in this way, you can have a multi-level model and estimate this model. Spatial, just because you have district level, don't jump into spatial analysis. Another very important problem, in fact, there was a very classic paper written on this. See, in the recent parliamentary elections for West Bengal, if you remember what the newspapers said, BJP was winning most of the assembly constituencies in several parliamentary constituencies. So that means if I take a parliamentary constituency, BJP was winning most of the assembly seats within this constituency. But TMC won the parliamentary seat. This is not something which is very new. There's a classic paper called by Openshaw. The title is More Than a Million Correlation Coefficients. So over here, Openshaw pointed out a phenomenon which is called gerrymandering. It's a very common practice in the United States where the administrative boundaries are manipulated to influence election results. So Openshaw looked at presidential voting patterns in Iowa state. And he first started with wards, and he found that the trends show that one person was winning. Then he moved to higher administrative levels. And what he found was, depending upon which level he was taking, the winning candidate, identity of the winning candidate was changing. So if it is what, let us say A wins, if he moves up to a higher level, B was winning, a third, even higher level, A was winning. So he called this the modifiable area unit problem. And the importance of the problem is that if you study a spatial econometrics, any spatial econometric problem, the result will depend upon, or the result can depend upon, at which level you're studying the problem. What is your regional level? Is it state level? Is it district level? Or is it block level? Okay. For instance, let me discuss one of my PhD students' work. She was trying to look at a hypothesis called the diffusion hypothesis. This hypothesis says that if you have two neighboring regions, they are going to behave, there will be cultural exchange between them, and they are going to behave in a similar manner. And what she wanted to do was look at fertility behavior between West Bengal and Bangladesh. Both the regions are in two different countries, but they have a long cultural history and there's cultural exchanges between them. There's migration and people come over both legally and illegally. And in some places, like for instance, if you go to Taki in North 24 Parganas, there's a river which the Ishamoti River separates the two countries, Bangladesh and West Bengal. During the pujas, the border is opened up and people can cross over. You also have illegal migration, smuggling, etc. when people cross over the river illegally on other days also. So what you have is, you have exchange between the two places taking place. When we looked at the data at an individual level, we found that there was diffusion. The fertility behavior in West Bengal was influencing the fertility behavior in Bangladesh.
Zakir da, just sorry to interrupt. Are you changing the slide? Because from my side,
No,
slide
no.
Okay.
No, this is modifiable area unit problem.
Okay.
Achha. So what happened was, what she found was that at the individual level, if you were located on the border, there was diffusion. Then, because we were learning, at that time I was trying to learn spatial statistics, and we decided to apply spatial statistical problems to this diffusion issue. So we looked at the problem at the district level using spatial statistics, and we found that diffusion was not there. The behavior, fertility behavior in West Bengal was not influencing the fertility behavior in Bangladesh. And the reason was that when you're taking a district, it is too large. If we could take the block level data, the neighboring blocks are, bordering blocks are going to be important. But if I'm taking the district, there are some villages which are close to the border and there's going to be exchange between them. But there's going to be the other districts. Let me just draw a diagram. That will make it easy. So let us say that this is this is West Bengal and this is Bangladesh. So you have blocks which are over here. Over here. There's going to be diffusion between these blocks. But if I compare two villages over here, there's not going to be diffusion. So what we were doing is, we were taking the district level, whereas we should have taken a much smaller unit, the village level or at least block level. So you have to be a bit careful. If you apply spatial analysis and you don't get good results, think whether it is because you have taken the wrong unit. Another problem, this should be obvious to all of you. If you see this data, you will see that there's a very high proportion of car thefts in this zone in San Francisco. But what we are looking at is simply the number of car thefts. We should actually also consider the denominator. How many cars were parked here? So out of 1,000 cars, 2 cars were stolen. On the other hand, out of 10 cars, 3 cars were stolen in this block. So we would say that the risk of car theft is much higher over here. Although the number of car theft shows or appears to indicate that this is a risky zone to keep your car in. Another problem is that you're going to face if you try to apply spatial analysis is the change of support problem. You have a shapefile. The shapefile will give you a certain, up to a certain level. So you have state level, you have district level. But at the all India level, you don't have block level data. Now the problem can be that in some cases, some of the variables that you're using in your analysis, they are obtained for different administrative regions. For instance, you have a variable which is available only at the state level. You have another level which is available at the block level. And the third variable is available at the district level. So the third variable is fine. It matches with a shapefile. The second variable, it is available at the block level. So what you can do is, in that case, you can aggregate it up to the common level. So the block level data can be either aggregated, you just take the sum, or you take the average, or you take the percentage, whatever, up to the, and find out and convert the variable to a district level variable. But the problem in that case will be, again, the problem of modified area unit problem. If you take a lower level, you can always convert a lower level to a higher level, but whether it is appropriate or not to study the phenomenon has to be considered. But if you have a state level and your shapefile is at the district level, then you're gone because you can't break it up. So you can always move from lower to upper, but you cannot move from higher levels downwards. We have not discussed Bayesian statistics over here, but one possibility is if you have this type of problems, you can either interpolate or impute using Bayesian approach. The last point is, finally, think whether location is important. If you're changing your location, will your of course, the behavior will be different because you have a different set of people. But do you have spatial dependence? Do you have spatial heterogeneity? If you have these, then only you should go for spatial analysis. Otherwise, I would say just go for an exploratory analysis, show the figures, draw a map, but don't go for spatial regressions or don't go for LISA, etc. Particularly if you find that there are no clusters. So the Moran statistics, global Moran shows a very low value. Or when you go for the local Moran's, local autocorrelation statistics, either the LISA statistics or the Jetisort or whatever statistic you use, unless they indicate that they are clusters, there's not much point in going for spatial regression models. So instead of jumping into spatial regressions, I would always say try to do the exploratory analysis carefully. Draw the maps, see whether you're getting, the choropleth map will give you clusters. Boxplot will show you whether you have outliers. If you have categorical variables, use the unique value or co-location maps, see whether there's a distinct regional variation.
Sir, I have a question.
Yeah, yes, please.
So basically, this is to do with my own research work. So I'm just asking your opinion on it. So basically, for my data, I am seeing that there is global autocorrelation, but no local autocorrelation. So in that case, so I am not getting local clusters, but I am getting significant results for Moran I. So in that case, should I be looking for to do spatial analysis, or should I not do so?
Mm, I would say that your spatial possibly may not be very successful. I mean, see, if you have a very high global Moran
Yes, sir.
and you also have clusters,
Mm.
go for spatial analysis.
Okay, sir.
If you have low values for both,
Mm.
there's no point in going for spatial analysis regression.
Right, right.
You're falling into the somewhat gray area. One thing
That's
you
right.
can do is you can do two things. One is check whether there is spatial regimes.
Okay, sir. Spatial regimes.
Yeah, try to find out if you have spatial regimes. Break it up so you can break up the data into some sub-regions and
Yes, sir.
see whether you're getting better results in one of them.
Okay, sir.
Alternately, you can also try the geographically weighted regression models.
Okay, sir. Okay, sir. Thank you so much, sir.
So it was a very it was a coincidence, but that was the point at which I wanted to conclude today's lecture. Let's check whether there are any clusters, check the local and Moranzai, and then decide whether to go for spatial models. And if the model does not come out well, check whether there's any spatial heterogeneity. The SAR model, the spatial error model, all of them incorporates only spatial dependence, not heterogeneity. But if you include either regimes or if you bring in a GWR model, it may give you better results in those cases. Just check. Another thing, so I forgot this point. This was if your regression is okay. Anyway, it came to my mind and then it slipped out. If I remember it, I'll post it in Google Class. So be a bit careful whether you have spatial dependence, spatial heterogeneity, and try to plot them. Now, one of the things, Geoda is very convenient to start with because it's menu driven. The exploratory part particularly can be done very easily, but the disadvantage of Geoda space is, what I wanted to discuss was spatial Durbin models. I'll come to that. The limitation of Geoda space is that there are two limitations. First of all, you cannot do GWR, nor can you do can you calculate the marginal effects. As you know, In a linear regression model, the regression coefficients gives you the marginal effects. If x1 changes, how much will y change? It is given by beta 1. In case of any nonlinear model, Logit-Probit for instance, the marginal effect is more complex. In a spatial model, what happens is, again, you have something like this. This is a region. And what happens is, as x goes up over here, this leads to y increase in this zone. This is what we call a direct effect. But we also have a neighbor. So when y goes up, it is going to increase y over here. So if this is y1 and this region is y2, y2 is going to go up. If y2 goes up by the same logic, it is going to affect y1. So that means x has a direct effect. It directly increases y1, which is captured by beta. But it also has second round effects through the spatial dependence model. So if you have a spatial autoregressive format, then there is going to be interaction between the y's. And this leads to an indirect effect. So in many spatial models, we would strongly suggest that you also report the marginal effects. Don't stop at the regression models, also go to the marginal effects. The problem is, unless you use R, Python, or Stata, it has to be above Stata 15. 14 will not work. Spatial models will work only Stata 15 upwards. So Geoda space will not give you marginal effects. You have to use the other packages. The other problem is the spatial Durbin model. In many cases, just one second. Okay. In the spatial model, often, what you can do is look at the clusters. Okay, the multivariate query shows you whether y and x are correlated or not. But also try to look at the clusters that for y using the Lisa or Jetty sort. Also look at the clusters of x, x1, x2, etc. and see whether the two clusters are coinciding. There's no statistical test or map for it. You just have to put it side by side and look at it. If the two matches, then the spatial Durbin model is strongly recommended. So in that case, you have to go for, you already have wy, but now you have to use wx. The problem in case of wx is Geoda space doesn't allow spatial Durbin models, but you can calculate it very easily. So you can calculate lags, save it in your data file, and then include it as one of your dependent variable. So spatial Durbin models can be calculated using Geoda space. As you have seen, regimes can also be calculated, but not GW. Another problem is, or limitation of Geoda or Geoda space is, in Stata, you can use a combination of weights. So you can use a contiguity weight for some variables, and you can use a geographic weight for other variables. This option is not given in Geoda Plus. You have to use only one variable as far as but we haven't covered it. Let me just see. Whether you can load several 2 or 3 weights or not. So we have a weight manager and we load so we can load several files, several weights, but at the same time, but if you go for regression, I'm afraid you have to choose between one of them. You can't choose both. So you can load both of them. If you have multiple weights, you can load both of them, but for your analysis, you have to choose only one. So this is another limitation of Geoda. But given all these limitations, the biggest advantage of Geoda is, and Geoda Space is, it's very extremely user-friendly and you can handle it very easily. If you search for Geoda, just Google Geoda and you will see they've got Anselin is preparing a workbook on Geoda. I'll also post, if I've not already posted it, a workbook on Geoda Space by a Latin American econometrician. So it's very easy to handle. It's menu driven. And even if you forget Geoda, if you forget R, you can forget Stata commands, but Geoda Space, you can always pick it up. And because the help is given online in the workbook, working with Geoda will be very easy. So, in spite of all Geoda's limitation, I always suggest people to start with Geoda. Once you get confidence, you can move up to better packages, particularly to R. R, we have found, is stronger than Stata. You can't do GWR in R, in Stata, for instance. Okay, so I'll stop at this point, and next day we'll just on Thursday, we will just, if you have any questions, now I'll try to answer it. If you have any questions, if you're facing some doubt in your research,